Hello, hello. Today we're going to be making tic-tac-toe. So before we begin, I just wanted to say I'm just going to be making the bare logic, just nothing else. Um, you can make it look nice. I've never been good at doing that, so I'm just going to do this. Cool. Okay, let's start. So from the top, we're going to be looking at this board. So this is a dictionary. So for Python, that just means a map. And for those who aren't exposed to any coding background, a map is a key value pair. So you can think of it as these values are your keys, sort of like the actual keys on your keychain to open your house. So this key opens this house, and this house has this stuff inside. So right now, that's nothing. It's just an empty variable. So it just has an empty string to represent this spot on the board has not been taken. But soon this will be filled with X's and O's to signify that that place has been taken by this person. Cool. Alright, so next part, we're going to scroll down. So this is a simple function that I've defined here. So this just is going to give our users some instructions on how to play the game in case they've never played a game that's everybody's played forever. So it'll print out, so here we define it, and then it's going to print out hello, blah blah blah, player 1, player 2, you know it, and then a board. Cool. Okay, following that we get to the actual game portion of this. So this is a function that will accept 2 players. We haven't defined what those players will do yet, or what these even say. So we're saying that player X, which is going to be our player 1 for this, will go first, and there are 0 turns starting now. So next we're going to try, which is just it's just this thing that attempts to do a section of code, and if it fails, we go down here and we print something out. So what I'm doing here is not the best thing to look for. I just add it there just in case there is a situation that I don't want to deal with, or that I'm not expecting. So for you, you might actually want to specify what exception you're looking for. So just food for thought. Okay, so following that, so now we're going to attempt to perform this game function. So while our count is less than or equal to 9, which is just how tic-tac-toe goes, there are only 9 turns because there's only 9 places on the board that you can put your stuff on. So player blah blah blah, it's your turn. He puts in their move. Then from there, I check if that move is even valid. Going on. If that place on the board isn't taken, then cool, that's a valid move. Else, I can't do that. So from here, we say continue. Continue in this context means redo the loop again. Continue usually just means exit the loop and go back in on the next cycle. There's also something else that you could do called break, and that just exits completely. Okay, so moving on, we have player blah blah blah. So now we're updating what player goes where, and if we get past all of that, then we can increment our count. Okay, so we incremented our count, and now we know that it's one more turn. So we know that after 5 turns, then we will have, that's our minimum requirement for a win scenario. So it would go XO, XO, X. That means 3 X's. So that's the earliest time you can say someone has won. So after this situation, I'm going to check diagonals, horizontals, and vertical lines. So what am I doing here? And what could you use this for? So on this first line, I'm saying move modulus 3 equals 0. What does that mean? So let's put a number in and let me explain. So if I do 6 modulus 3, that equals 0. What I'm actually saying is, how many times can I take out 3 until there's no 3's left in it? So 6 minus 3 equals 0, obviously. But if I do 8 modulus 3, it will equal 2? Yeah, 2. Because what I'm doing is I'm going to keep subtracting from 8. So I get 3, and that gives me 5. And I'm going to subtract 3 again because I can, and that gives me 2. But 2 is now too small to subtract a 3 from, so that's all you have left over. It's the remainder. Cool. So what does that mean in this context, though? How am I getting the last row? So if I do get modulus 3, then I know equals 0, then I know that that value is either 3, 6, or 9. So that means, in the context of our board, that it's actually probably easier to look up here. Let me just take this so you can see it. So 3, 6, 9. Oh God, my God. Okay. So we have one of these. And now we know that we're in the last row. Well, the last column. And we got to move forward. So we go 9 minus 1 is 8. 9 minus 2 is 7. Or in the other case, it's 3, 2, 1. So we're getting this whole row that we can compare. Why am I doing this? You can actually compare them directly. 1 equals 2, 2 equals 3. I just like doing this because I didn't want to do too much thinking. I don't like direct comparisons. I'm picky, I guess. You don't have to do it my way. It's not that important. So following that logic, you would get 2, 5, 7, and you'd have to check the 2 beside you, and then for 2, you'd get the first row, and then you'd have to check the ones to your right. Now, what's happening down here? So I'm saying move minus 1 divided by 3 equals 2. This is, again, a little more complicated than I wanted it to be. So I need to... Okay, yeah, let me explain this for a second. So let's say we have our last value in this column, or in this rows, and let's say we have 7. So I just want to know, is it 0, 1, or 2? So I take away 1. Because I don't want to have the max value of 9, which would give us 3, which is a little wonky. So after I do that, I have 6, and then I can divide it by 3, which gives me 2. So why is this 2 value so important? It's in order to make this all uniform to one number. So nothing here would be greater than 3, so it would end up being 0. That's because this changing into an integer means we're changing it to a whole number, and it'll actually round down. That's just how Python will work. And it'll give us 0, 1, and 2 for those rows. And then again, the same logic as before. We just look up or down or up and down. And that's how those columns checks would work. And then following that, the remainder, I didn't have a clever way of doing diagonals, so it was just checking directly, which seems silly because I just told you that I didn't want to do that, and I did it anyway. Yeah. Okay, and next, after we have all those checks, we went through all those steps. If we didn't find a win in any of those times where we would pass a winner to the winner function, then something cool would happen. If that never happens and we reach to the 9th turn, that means there's no more places on the board to put in. So I'd print the board out, and then I'd say it's a tie, because that's what it is. But for every other turn that happens, I need to print out the board anyway, because I want to see what's happening. Let me remove this, and then we're gonna, because soon we're gonna need to test it, or at least I need to prove to you that it actually works. So when you run it and you're like, oh, it doesn't work, you can't really blame me, or I guess you could, I don't know. So following that, we get to our winner function. It just prints out a winner, just tells you the name. So right now it's just gonna print out X or O, because I didn't care enough to do that. But yeah, you could fix that if you wanted to. Then print board function, that's just so we can see what's happening on the board. Input usernames. I wanted to put this in just because I was like, oh, maybe you want to play against your friend, but why would you play against your friend on one computer? That seems a little odd. But if you did, it's there. You're welcome. And then finally we get to the end of our program and also the start of our program. So instructions prints out the thing from the top that we talked about, A and B, we put in the names. So here it inputs the names, your user puts in the name, and we'll return the two values, and then we're going to set them to these variables, and then we're going to pass those two names to here. I don't know why, because I never ended up using them, but that's why they're there. Anyway, let's run it. I have forgotten where I am. Cool. Games. Cool. Alright, I'm not gonna do any real time testing right now, so I'm just gonna do the basic one. Me, you, 3, 5, 3, 6, 2, and I won, and you lost, and now you can stop watching now. If you have any questions, leave a comment, and if you want the code, it's going to be in the description. If there's anything else you want or want to see, just let me know. Anyway, I'll see you around. Bye.